Yeah.
Okay, so we don't know what's happening with map testing. I think it depends on, yeah. I was hoping that map testing would be today and tomorrow. If it's tomorrow and Thursday, then I don't want to give a test, or I don't want to give a quiz if the class is shortened. So I mean, maybe I'm pushing it to Friday. I don't know. I don't want to, but if I'm doing that, then just know that I'm going to be just covering new material each. Now, it's not a big deal because everything that we cover is really, we're kind of reviewing for 2.1 and 2.5 anyways. It just feels like an easier version. But I know that some students, with the long weekend coming up, maybe you're not here Friday. If that's the case, then you can just find any time on Thursday to come if I'm not, for some reason, not giving a test that day, you can just come anytime Thursday to take the test if you want to take it early. Okay, yeah. I don't want to do that. It depends. It depends on the schedule, right? If they're telling us that that I'm hoping that we can get some clarity, because I'm hoping between Thursday and Friday that one of those 2 days will be a regular schedule day. But if it's not, then
I think.
yeah.
Wait, how long is the quiz for page? Is it like?
It is 3 pages.
Okay.
3 pages. Yeah, shorter than the review. Okay.
Oh, you mean like front, back, and front? Or do you mean like front, back, front, back?
Front, back, front.
Okay, sounds good.
Yeah, shorter than your review.
Got
it. So we're going to start chain rule. Now, I try to organize your packets, hopefully a little bit easier to follow. So I put all the homework and the AP review next to each other, in the order that you're doing it, so that you're not having to flip through all these different packets. So just one packet, and it should be pretty much chronological. I think for 3.3, I split into 2 parts. So the assignment may be a little further back, but hopefully it's easier to follow with this new format. I do want to point out something though about homework. As you guys are doing your homework, I want to see your homework on a separate sheet. I feel like when you guys are working on the margins of the exercise pages, it's not enough room, and it's not enough for me to know whether you are showing your work. So from now on, I'd like to see your work on a separate sheet. And if you don't do that, and I come around and check, I'll just ask you to do it before I give you credit. Okay. And the second, and then the AP problems, I still space them out on separate pages. So I want you to do it there. But I want you to show more work than just circling the answers. Okay, I want to see that you're putting the effort, because circling the answers, that can take like 5 seconds, right? I'm not seeing that you're putting in the time. So show me that you're putting in the time. And again, if you're not doing that, then I'll just ask you to do it again, and then I'll give you credit. Okay. I'll send out a reminder this afternoon about that. And then I'm working on the chapter 3 or the unit 3 page on my website. So hopefully I can get that up to date by today, so you guys can check your homework and things like that. Okay. All right, so we're going to start chain rule today. Yes. So I will update it today.
Okay.
Yeah. So I'll work on it today. Oh yeah, sorry. So my bad. Yeah. So you do have to pull a. Yeah. Sorry. So hopefully tomorrow I'll get that up. Okay. So now we're dealing. We've dealt with what happens when we want to find the derivative of 2 functions that are multiplied together. So the product of 2 terms, we have product rule for that. if we're dividing two terms, we can use quotient rule for that. But if I have a composition function, if I have a function within a function, then we call this chain rule. Okay, so chain rule is how we're going to use the derivative, or this, it kind of, sometimes it's easy to confuse it with product rule. It's a little bit different than product rule. So here I want to make sure that we understand that, let's say we have f of g of x, right? So there's an outside portion, which is this f function with whatever's inside. And there's also this inside function, which is that, in this case, the g of x. Okay, so basically, when we find the derivative, we're going to be taking turns with the outside and inside separately. Okay, so let's just go ahead and identify the outside and inside portions of each of these. So here you can kind of tell that sine is the outside function and x squared is the inside. So I'm going to say the outside function is the sine parentheses, and then the inside function is the x squared. Okay, for square root of natural log of x, I can rewrite this as parentheses natural log of x raised to the 1/2. Okay, the outside, what's the outside portion? Yeah, it's just the square root with the 1/2. Okay. Whatever is inside the parentheses is your inside function. So the inside function is the natural log of x. Okay, this will become more relevant because right now I just want us to be able to identify the outside inside. Then we can talk about the calculus portion later. So in this case, we have the outside function, which is the cosine. And then the inside portion is the sine of 5x. Okay, so here's chain rule. Chain rule is what we do if we see a composition function or composite function, or you see a portion inside a larger expression. So let's say the outside is defined using f, and let's say the inside is defined using g. If there's an outside-inside portion, the way I find the derivative is I find the derivative of the outside portion first. But when I take the outside portion's derivative, I'm going to leave the inside intact. I'm just going to copy down my original inside function with no changes. And then when I'm ready for the inside function, I can do multiplied by the inside function derivative. So this is what chain rule is, but some students, I see some students, they feel, sorry, I'll say this. The tendency is that we want to create our own chain rule. And I see some students do this where they take the derivative of the outside function followed by the derivative of the inside function. Okay, so this is not correct. Okay. Even though it feels more efficient, it feels like you're doing both things at once. That is not chain rule. Okay, you have to take the outside function's derivative with the inside function intact, let that be its own thing, and then in the separate space, you can take the inside function derivative in its own space. Okay, so we can't do this. All right, so let's say we have a function that is x squared minus 5 to the 4th power. Now, if we didn't have chain rule, then we'll have to go through power rule. But to do power rule, I got to FOIL all this out, and that is not efficient, right? We don't want to be, I mean, if we FOIL, we prefer to just do it with squared, right? That's the most we want to do. Anything that's higher than 2, we're not expected to do that, and we have more efficient ways of doing it. So, but however, what if we think of this as an outside and inside expression? Then we can think of it as two different expressions, a function within a function. So the outside function is basically whatever you see outside the parentheses. So I can think of this as, what's the outside portion? Or parentheses to the 4th, right? So I can think of that as, I could do a derivative with just that expression, okay? And then the inside portion is the what? Yeah, it's whatever's inside the parentheses, x squared minus 5. So I'm basically just going to take turns with the derivatives one at a time. So let's do the outside portion first. So imagine parentheses is like its own variable. Pretend like this is an x. So what's the derivative of x to the fourth? Normally, you would say 4x cubed. So what's the derivative of parentheses to the fourth?
4 parentheses cubed.
4 parentheses cubed. So we're activating this portion of the chain rule. Now, what do you think we're going to put inside the parentheses? Yeah, the original expression. Don't put 2x, right? We're not ready for the derivative just yet. You got to put x squared minus 1. Okay. Now we've only taken care of the outside function's derivative. We still need to do inside's derivative. So that's going to be in a separate space, separated by multiplication. So times, what's the inside's derivative? 2x. Much more efficient than having to FOIL everything out, find the derivative using power rule, and then pushing it back together. Now, this is fine. I just like to clean things up if it's easy to clean up. So I'm just going to put the 4 and the 2x together, make it 8x. Any questions here? Okay, example 2, g of x equals root 4x minus 3. There's you can tell that there's an inside portion to this expression, but maybe let's get the radical to go away first. How can I rewrite this function? X minus 3 to the 1. Okay, so we can clearly see the inside portion. Okay, so we take turns with each of their derivatives. What's the derivative of parentheses to the 1/2? Yep, just do power rule, 1/2 parentheses to the negative 1/2. Fill the parentheses with the original, okay? The original inside, don't put 4 in there. We're not ready for that yet. Okay, so now we're done with the outside portion. We've taken care of f prime of g of x. Now we're ready for the inside, the g prime. What's 4x minus 3's derivative? Okay, so I'm just going to clean this up here. The 4 divided by 2 is just 2. The parentheses are negative. I'm going to push that down to the denominator. You can leave it as rational or convert it to radical. I'm going to just do radical just to give another variation. So no matter how complicated our derivative rule gets, just keep in mind the purpose of it is just to describe the slope behavior of the original, right? It's the end result is still the same as any of the derivatives. It's just trying to create some formula that will relate the slope of any point on the graph with the x value on the graph. Okay, put a star next to 3. This is the most troublesome ones that students potentially have issues with. And the issue is that squared is not written in a way that is easy for us to identify the need for multiple or a chain rule within a chain or multiple chain rules here. So whenever you see the shorthand notation, my suggestion is always put it in a less efficient manner. That way you can see every piece a little bit more clearly. So, but if you don't do that, you run the risk of not seeing the full effect of chain rule. So put a star next to it. So anytime you see the shorthand way, rewrite it first. It'll help you immensely in terms of seeing the multiple chain rules needed. So what is this squared impacting? The whole sign, the whole expression. So I'm going to write it this way. I'm going to say bracket sine of parentheses 5x. I know it's not as efficient with a lot more brackets and parentheses, but this is going to be much more visually useful for you to see the chain rule pieces involved. All right. Now that you see this in front of you, there's obviously multiple parts, function within a function. What's the outside portion that you see? Squared. Yeah, the brackets or parentheses squared. You got to take that derivative first. And then the inside portion is the what? Yeah, sine of 5x. But then there's also a little bit of chain rule there as well. So, but we'll get to that. Okay. Actually, you know what? Let me do it this way here. I'm going to say sine parentheses because there's an inner portion, which is the 5x. So we're basically having to chain multiple things together. Okay, but we'll do one thing at a time here. Bracket squared. What's bracket squared's derivative? Yep, 2 bracket to the first power. Right, x squared is just 2x, so bracket squared is just 2 bracket. Okay, what goes inside here? 5 again, original, right? No changes there. So we're done with that one. Now we're down to sine. What's sine's derivative? Cosine. So cosine parentheses, what goes inside here? 5x, right? We're not ready for 5x just yet. Well, I mean, we're not ready for 5x derivative just yet. Okay, so now we're done with the middle portion, or we're down to the innermost portion. What's 5x's derivative? 5. So it's almost like 3 layers that we have to kind of sort through here. Now to clean up, I'm just going to push the coefficients together. Yeah, so when I go through a new set of rules here, I'm going to say sine's derivative is cosine of u times u prime, and that can eliminate the inner portion. But for now, I want to kind of lay this out. I mean, were you getting a different answer?
No, I was just wondering if, like, we can always combine the coefficients or if it's.
Oh, okay.
Kind of like similar denominator. Or similar power.
I probably need to see an example.
Like if it were sine of 6x times cosine, never mind, they're multiplied.
Right, then I have to leave it. Yeah, I can't multiply anything that's inside the trig. Okay. Okay. Okay, so number 4, there's also inside outside portion. Okay, what's the outside portion here? Natural log parentheses, and the inside portion is the x cubed. Okay, now the derivative of natural log is just 1 over x. So the derivative of natural log of parentheses is just 1 over the parentheses, which we can fill in with x cubed, times the inside function's derivative, which is x cubed, which becomes 3x squared, which we can clean up to be 3 over x. Another way that we can do this is we can actually clean this up further. We have power property available to us with natural log. We can actually bring this exponent down without changing anything. So I can actually do this first. These are the same things because exponent can be free to move as long as I'm inside the natural log expression. So if I can get it down to this, then there's no need for chain rule. I can just do 3 times 1 over x, which is the same thing as 3 over x. Oh, okay, sorry. That's what I was going to do with number 5. I wrote this out twice to show 2 different methods. Okay, number 6. What's my, obviously there's a need for chain rule, outside, inside. What's the outside portion? Parentheses, cube. What's my inside portion?
T squared plus
Mhm.
1 over 2t minus.
Yeah. So the outside, I'm going to use power rule, but the inside, I got to do what? Quotient, yeah. But one thing at a time, right? We always got to take care of the outside first. So what's the outside's derivative? Mhm. What can I put inside here? The original, right? All this mess. So now, once I'm here, I got to activate my inside's derivative. So I got to do quotient rule, right? Quotient rule. So I'm going to leave a lot of space here for quotient rule. F prime g minus f g prime all over g squared. So f, this is my f up top. This is my g below. Now I want us to be able to clean this up reasonably. So I'm going to FOIL out as much as I can here. Once I FOIL this out, I should be able to just kind of push all these together here. So just want to show, use the space here to FOIL all this out here. So 4t squared minus 10t minus 2t squared minus 2. And one thing I want to point out is that when we merge this together, what is this exponent 2? What is this impacting? Okay. But is it just the top? The top and the bottom right? But both the numerator and denominator are getting squared. So the reason why I point that out is because if we don't pay attention to that 2 for the bottom, we may think of that the denominator may only be 2t minus 5 to the third power. Right? We see this, we don't look at that 2, we look at that 2 for the top, but not for the bottom. So just keep in mind that this 2t minus 5 is actually being squared. So if I merge these together, there's actually 4 of them down there. So whenever I see this, I like to kind of separate them. So I can clearly see that, okay, that 2t minus 5 is also getting impacted by that exponent, even though it's all the way up here. And that helps me see things a little more clearly. I can push that together and make sure I do 2 plus 2 is 4 and not equal to 3. And then I think this is a good place to be, just in terms of getting it factored form and getting it into a nice clean form for future purposes of when we have to do curve sketching. And also, if this was AP exam multiple choice question, this is probably how they're going to get their answer to. So you want to be able to, even though pre-response, you know, this is acceptable for pre-response, I want us to be able to know how to get to a relatively cleaned up version. And by relatively cleaned up, I mean factored form. So I don't want, you know, usually that doesn't mean you FOIL everything out. You want everything in nice parentheses. So before we go to the next page, if you can turn to page 45. 45 is the list of rules that you've already memorized, probably for the most part. But this is how I like to memorize my derivative rules. Obviously, this is not required for this quiz coming up, but this is what I like to use as I memorize formulas. Basically, all these derivative rules has a u prime. That u prime just basically has a chain rule built into the derivative. So I'm always looking for that chain rule that's built in. So I like to, because most problems, derivative has a chain rule portion of it. So for instance, if I ask you for what is the derivative of sine of 6x squared plus 1, it's nice to just be able to understand, okay, cosine of u times u prime, that you're always looking for u prime, even if it's nothing more than just the 1. But here, you can match it up a lot nicer, right? Sine's derivative is simply cosine of u times u prime. So I like to have that. Basically, I put a u prime for every derivative as I'm memorizing it, just as a reminder that, okay, I'm always looking for that inside portion of derivative. That's my preference of memorizing rules. But again, you know, we're a little bit ahead. This is not on the quiz. There's no chain rule. So technically, all the u prime on the quiz will just be times 1, right? Okay, so back to page 7. Sorry, page 2, number 7. Okay, g of x equals 2x root 1 minus x, find g prime of -3. We got to find g prime of x first, right? Before we can find g prime of -3. So to find g prime of x, look at how this is set up. Can I expand this out and rely on power rule? Okay, order of operations does not allow me to do it, distribute that through. So I really need to think of this as two separate things. And there's a need for what rule here? Yeah, product and chain. Yeah. So the reason why we need product is because 2x and 1 minus x are obviously separate expressions outside of each other that are being multiplied. But then the chain rule, because within g of x, the inside-outside portion is going to produce a -1. So there's a little bit of chain rule going on here as well. All right, but product rule first. Okay, so if you're ever deciding, how would I know which rule comes first? If there's a mixture between product and quotient, or product and chain and quotient, how do I know which one is first? So here's the rule of thumb. Whatever affects a larger portion of the problem is the first rule that you apply. Okay. So if parentheses is over the entire expression, that means chain rule is probably first, because chain rule is going to have an impact over the entire expression. So for instance, number 6, if I see parentheses over the entire expression, that's the indication that chain rule is going to come first, and whatever's inside is going to be come next. But this one here, parentheses is not over the entire expression. That means there's a larger rule impacting the problem than chain rule, and it's the product rule. So product rule has a larger impact on the problem than chain rule, so product rule comes first. Okay, f prime g plus f g prime, f prime 2x becomes 2. We keep the original g function. Back to f, g prime. So we do a little bit of chain rule here. So outside is my parentheses, so the 1/2. Inside is the 1 minus x. So outside's derivative is 1/2 parentheses to the -1/2 with the inside function intact. Times the inside's derivative. What's 1 minus x's derivative? -1. Let me just do some cleanup here because we still have to find g prime of -3, right? So I'm going to clean up here. So 2x. So the reason that I was able to get this cleaned up to this expression is because I saw the 2 and the 1/2 can cancel out. The x stays up top along with the -1, and then I brought the square root down to below. You can leave your answer. You can leave your. You don't have to put radicals there. You can put parentheses to the 1/2 if you want. But now that I have g prime, I can find g prime of -3. Oh, thank you. Yep, just 2. Thanks. Thanks for that catch. Okay, any questions with 7? Okay, does anybody still need to look at this? Can we move on?
Oh, right, so that's chain rule, right? So the outside derivative is the parentheses of the 1/2, and that becomes 1/2 parentheses of -1/2. And then the inside portion is 1 minus x, so derivative of 1 minus x is over.
All right, everybody good here? Okay, now let's talk about chain rule if we're in function notation. So let's look at these examples there on number 8. Find f prime of 4. Okay, but before we get to f prime of 4, let's build f prime of x first. So f prime of x here, we can definitely tell there's an inside outside portion. There's a need for chain rule here. What's the outside portion? Parentheses squared. The inside portion is the g of x. So we know that we got to go through chain rule. So what's outside's derivative? 2 parentheses. What goes inside the parentheses? G of x. Times inside, yep, g of x is the inside, so the derivative will stay in function notation as g prime. So now we just replace every x that we see with 4, and then we can, one thing at a time, get it out of function notation into a numeric values. Okay, for next one here, root h of x, let's rewrite it to make it a little bit easier to see the pieces here. Okay, again, outside, inside. Oops, no, h of negative. H of 4, my bad, h of 4. Okay, next 5 minutes or so, see if you're able to get through 1, 2, and 3. Middle of the page.
Yeah.
Hey, everybody good? With these problems here, I can show 1, 2, and 3 below.
Just this.
It should be all like, so if you want your 5 to be X, 5 to be X, valid 5, but 5 to be X is cancel and give this other balance. Yeah. It's like, but it's ridiculous and things. Well, you write it down. What? Yeah. But. What, yeah.
Can you explain number 5?
You're right. But yeah.
Yeah, there's, I think the easier way is to go through that product property, bring that X down. But you can also go through the derivative rule, for 5 to the X, which is a little bit more involved there, so.
Why can you bring the X around?
The reason why is because if I have a natural log of a to the n, I can always bring that exponent down with no issues, right? It's a product
What
property.
if you have L and 5A? Doesn't that become 5L and A? As well?
Say again?
If you have L and 5A, can that also be?
Like this?
No,
Or
no, just
like-
regular.
like that?
Doesn't that also, can't that also become 5L and A?
Not if it's this. If it's this, then I can use product property. I can say natural log of 5 plus natural log of A.
Okay. I thought you did that earlier.
But yeah, we could do the messier version there. I mean, the derivative of A to U.
Wait, for number 5 on the front page. Oh, it's a power. Okay, never mind. Got it. I was saying number 5 on the other page, but that was to the power as well, so I was,
Right.
yeah, okay. Oh, okay.
Yeah, for 7 and 8, it's so important that you take the time to bring that exponent outside the entire expression. That way you can clearly see the need for chain rule and you're not accidentally skipping a portion that needs to be involved. So, yeah, number 8 seems pretty harmless. But if you don't bring that exponent outside, it's easier to make a mistake. Okay. So I think it's always a good idea to bring that exponent out, put it in that more helpful form, even if it feels messier with the parentheses, but with the brackets. But you can see the need for chain rule better and can identify the parts easier. Okay, so you guys have homework tonight. Check your calendar. Everything is inside your packets, hopefully in the order that makes it easier for you to find your pages. Make sure you do your homework on a separate sheet, and then on the AP problems, make sure you show your work. Don't just circle the answer, but show me your work. Okay, I'll send out a reminder tonight, and I'll also try to have chapter 3 page on my website with enough resources where you can check your answers and you can have everything available to you. All right, go get your phones. On Thursday, yeah. Right now, our test. Oh, right. Right, yeah. Guys, tomorrow morning, I will have a help session for the 2125 quiz. Okay, I'll send out a reminder for that as well. So tomorrow morning, help session 7:15. I'll send you a link. You can join the Remind as well. Oh, sorry, join the Remind on Teams.
Oh, yeah. It's like one over. Somehow it's like,
Yeah.
make it a personal one version. I see.
Speech.
Thank you.